All right, here we are, Chapter 3 notes, Part 2 of 2. We finished on nuclear energy. We did this last day, but inside the nuclear reactor, uranium-235 atoms are split. This is called fission. Releases an enormous amount of thermal energy. So there's a picture of the CANDU reactor, which I asked you to read about at the end of the class here yesterday. So you should have read and know a little bit about our Canadian CANDU reactor. The radioactive material presents some danger, and like I said, I think we did this yesterday too. And the tailings are the sort of the nuclear waste that's generated, the tailings, and they can be harmful too because there's some residual radioactivity there in those things. Oh my goodness, nuclear reaction right there. A lot of energy released. Okay. So the last part of this, let's see. I think there was a bit of a. Oh wow. All right, so I think asked you to do this. No, did we do this last day? Read and discuss the advantages and disadvantages of nuclear energy, and then on 72 and 73 were case studies of nuclear accidents. So I did ask you to read about that. Information that you would find on those pages and those readings are open for the quiz or the test, so they aren't in these notes, but I will ask you to read from the textbook about that stuff. So we are on 3.3 today. Okay. So we've talked about non-renewable energy sources, and now we're going to talk about renewable energy resources. So solar energy is something that we're all familiar with. This is energy from the sun. Solar is sun. It's so passive solar collection transforms solar energy into thermal energy without any special devices. Examples of this would be a greenhouse or a car with closed windows, right? When the sun's beating on it. That's a passive solar energy collector. So I have a little picture of a greenhouse there. The sun rays come in, heat up the molecules inside there, and there's all the heat is sort of trapped in there. And this is why the greenhouse effect is what they call the heating of the atmosphere of the Earth, right? Because sun rays come in, heat everything up, and there's just so much of this heat that's trapped and like that. So that's kind of the way there. So yeah, even a car with closed windows. Yeah, in the summertime. If you leave your window open a crack like this, it's quite a bit better if you can. If it's not going to rain or anything, if you're not afraid of somebody, breaking in or something. But if you can leave your window open a crack, especially on the cool side, it gets hot here, and then the heat will kind of like go towards the cooler side and let's go out. That's a good idea, so it doesn't build up too much. Active solar collection concentrates solar energy to generate electricity. Photovoltaic cells. So photo is like photons, energy packets. Voltaic is like volts, sort of electrical circuitry. They use solar energy to generate a current through a circuit. So anytime you can generate electrical current through a circuit, then you can use some of that energy that flows. Common examples of these are solar calculators and watches. Large solar cells can produce enough electricity to service whole cities. Okay, so on page 76, if you have your textbook there, or if you're near someone with a textbook, take a look at page 76, and we'll read and discuss the advantages and disadvantages of all this stuff. So we'll take a moment and do that. All right, wind energy is the energy of moving air, which causes large fans to turn and generate electricity in the rotation of large turbines. Okay, so a wind farm would be pictured here, where there's lots of like the big blades that the wind pushes. The blades are on a bit of an angle, so it pushes them in a direction, and they keep going, and you've seen them all spin. So the turbines would be like the circular kind of rotational motors that they turn on the inside, which generates an electrical current that is sent away to use. So yeah. Moving air, wind energy. Not too difficult a concept right there. Hydro energy. Okay, hydro means water, right? So hydro energy is the energy of running or falling water. Water flows through hydroelectric dams, causing turbines to spin, which generates electrical energy. Much the same as the fan blades on the wind turbines there, same kind of turbines. Just the water pushes the blades now. So when large dams are built, a natural stream or river is barricaded with the dam itself there, like a big wall, to create a large reservoir on one side of the wall. When this reservoir is created, the little river that now has a big wall built up there, the water level goes up on the one side, right? So when the water level goes up on the one side, if you have holes or doors in the dam, you can let some of the water through. And as the water is pulled by gravity down to the lower part on the other side, it can run downhill or it can run through and pass through these blades. And so it's like the energy of falling water. So gravity is pulling on the water, it falls down and hits the blades and spins the stuff, okay? Water passes through channels in the dam, which is like a large wall separating the high water level reservoir from the water at a lower level on the other side. So I'm not sure if you guys have been on a dam or seen a dam close up, but this is just a picture I grabbed off the World Wide Web. We have the reservoir on this side, a little higher level than what's on this side, and so as they let the water through in a controlled manner, the water that passes through there would kind of spin these turbines and generate the electricity that way. Okay, and they just keep this water level. They don't let it out too fast. They keep the water level at a high level on this one side. If they let it out too fast, it would equalize, and then there would be no difference in height. We'd have a problem. So they close it up, and they only let it through in a controlled manner so that you can maintain the difference in height, so that gravity will do its thing. Okay. Does that make sense? Am I going too fast, or is it pretty easy to understand? Okay. All right. Yeah, hydro energy. It's a big deal. We can use hydro, and actually, what we're going to talk about next here is the like the tidal energy, same kind of thing, but it's not built by a dam. So there are advantages and disadvantages to building dams. So take one moment right now and discuss with a partner what you think one advantage and one disadvantage might be. Just take 1 minute to do that. Go. All right, let's talk about geothermal. So again, remember, if you run across a word that you don't know the meaning of, try and break it up into its constituent parts, right? Like this one, geo, guys. Geo, right? That is earth, right? The earth. Thermal is heat. So it's the earth's heat. The heat of the earth. That's the energy we're trying to harness here. So geothermal energy is the energy that is captured from the earth's interior. So as you drill down towards the center of the earth, things get pretty warm. Now, just underneath the surface, if you're digging in the dirt, like this far down, it's cold. Okay, because, you know, the sun's not getting to any of that dirt, and it's fairly insulated. If you go down really, really deep, though, it starts to get warm, because we're getting closer to the interior of the earth and all that sort of stuff. So, like, I'm talking deep, 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 it gets warm, warm, warm. The most common use of geothermal energy involves the surface water being injected deep underground where it becomes superheated before returning to the surface. There's a little picture here of a geothermal setup for like a typical, you know, maybe a house situation here. This heat can then be used in different ways to heat homes or to generate electricity through steam engines turning turbines. So if you have the water hot enough and it starts to kind of like, you know, it's steaming water, that pressure, the steam passing through can also turn blades too, right? Okay, so superheated water from way down deep. So the cold water goes down here, it goes down, and when it goes down, it starts to heat up, and then when it comes back up, it's pretty hot, and then it funnels in and goes back in. So yeah, I actually know of friends of ours that have done this on their acreage out of town, and yeah, it works pretty good. They just pump cold water down these pipes that are just so deep, and then the water that comes up is really hot, and that's what they use for their hot water. They use to heat their house and all sorts of stuff. I don't know how deep it is. Good question. I don't know exactly how deep it is, but it is. I wouldn't even venture to guess. I don't know. I'm sure he told me once, but it's deep. Yeah. Okay. Anybody else have any questions about that?
You answered Hunter's question, like, as he put his hand.
Yeah, I was just waiting to answer.
Oh, which question did I answer?
I was asking if you can use that water to like heat your home. Or,
Yeah.
Like, is that how my shower gets hot?
Sure. Like even in this school here, we have boilers in the basement, right? We have some electric heat too, but like this is an older school, so we have big boilers in the basement. Super hot water gets pumped through the pipes in the wintertime. It's just the hot water that pumps through the radiators here. And then heat comes from those pipes. The pipes get really hot, and then the heat just emanates. And lots of places use small boilers now, like for in-floor heating and stuff. So in a big shop or like a big shop or a manufacturing place, a lot of times it's radiant floor heat. So they have pipes underneath the floor, like just underneath the floor, the cement floor, just inside the cement floor. And those pipes get super hot and they just run super hot water through it all the time. And then it just kind of like that heat just kind of like comes up and heats the building that way. And some houses have in-floor heating in the basement too. So there's no forced air, there's no electric heat. It's the floor is basically warmed right up, and then that heat just kind of like rises, you know, and heats the room. Yeah.
Is the water like from the pipes in the ground?
Is the water renewable?
Yeah.
Yeah, I think so. Yeah, I don't know exactly how all of these systems work, but really, if these pipes are filled with water, it's just a circulation. So, depending on, I mean, yeah, I wouldn't say you'd have to pump fresh water in here all the time unless you're using this hot water. Like if you're actually using the hot water, I don't know exactly how the systems work, but for the most part, I think that it would be, you know, all the same water that just gets hot and cold and hot and cold and hot and cold. Yeah. Good question, though. Yeah, it's a fairly closed system, I would think, for most things. Okay, next thing, biomass energy. Biomass. Biomass energy is the chemical energy contained in the bonds of non-fossil fuel organic materials, such as wood, vegetation, plant oils, and organic wastes. These materials are burned, transforming chemical energy into thermal energy. Biofuels such as ethanol are also used in vehicle fuel. Ethanol boosts the octane for lower grade fuels. So, sorry?
Sorry, have you heard of the Biobus?
The biobus? I don't know if I have. What is
It's
it?
really gross, and I think they only made one. But it's basically like a bus, and every seat is a toilet.
And every seat in this bus is a toilet?
Yeah, so like people
Okay.
literally go to the bathroom, and then they use it as fuel.
Okay,
for
so
part of
you
the bus.
So you sit down on the seat in the bus, in the midst of everyone else, and you fuel the bus.
Yeah.
Okay. Is that like from a movie or
No,
something?
they
Is that like real?
made one somewhere.
They made one somewhere, you think?
In like a book.
It sounds like the worst ride to school ever. I'm just saying.
It was like a book I read when I was younger. It was like,
We're almost there, kids. Come on, let's go. Did you eat your beans this morning?
it was like top 100 grossest things in the world, and that was in there.
Well, it was on one of the 100 grossest things in the world. That's strange. Strange it would make that list. Top 10 maybe. Okay, so yeah, apart from the biobus, one thing that normal sane people do is burn wood. So this is an example of heating your home with wood. Let's say fireplace. Yeah.
And food waste.
Yeah, the biobus. Okay, thank you for that. Thank you for that image. I am going to move on now.
I found out on BC News.
Yeah, I bet you did. Okay, close your computer now. All right, tidal energy. Let's wrap this up. This is really the last little bit here. Then we can continue to purge the biobus image from our minds. Tidal and wave energy is the energy of regular movement, not bowel movements, but energy movement of incoming and outgoing ocean tides. Thank you. You just destroyed this entire class. Incoming and outgoing tides. If the tide level is greater than 5 meters, a turbine can be used to create electrical energy as water flows back and forth through the turbine. So I've got a little picture down here. This is Bay of Fundy, Nova Scotia, Newfoundland, Nova Scotia. Yeah, Newfoundland, Nova Scotia. As the tide rises, like literally, you guys know about ocean tides, right? If you've ever been to the ocean, there's because of the rotation of the Earth, because of the draw of the moon and how the Earth and moon interact, literally the gravity that is exerted on the water, okay, the interaction between the Earth and the moon as the moon passes, the water gets sucked towards the moon, so tide comes up, and then the water level goes down, tide goes out. So if you've been to a oceanside city or town, you will notice that there are, you know, the tide is in, they say, and the water level is really high. Okay, high up on the shore. And when the tide is out, that means the water level is really low and the water is way out there, because every little bit of difference of the tide, the water is up high, water is way over there. So in the Bay of Fundy, because of these differences, as the tide comes in, it would turn the big turbine one way as the tide's going this way, and then as the tide kind of goes the other way, it would spin it the other way, I guess. And so there's lots of different kinds of tidal sort of turbines, but it's basically like a big fan underwater, and when the water moves one way, it turns it, and when the water moves another way, it turns it the other way. And so this creates sort of a back and forth movement of the water creates all sorts of generation of electrical current. So the Bay of Fundy tidal energy program there, you could look that up. That would be a good one to research a bit. And I think on page 81 of your textbook has a picture there, very similar to this, but it's on land, just kind of as a demonstration there. Yeah, and so that's the end of the material for chapter 3. Now, as I mentioned, it's good for you. It's going to be really good for you to read the textbook, read in between. I've just highlighted just the highlights for you in these notes. So really, you should be reading the surrounding information to get a good picture of what we're talking about. So, yeah, I'll give you your chapter 3 assignment that we need to work on here right now. Any questions? Yeah. Bam, bam, la, la, la. All right.